Today we're looking at section 9.2, solving by extracting roots. So we've been solving equations, quadratic equations specifically in this unit, and those are equations that happen to have a degree of 2 as its highest degree. And sometimes we'll need to solve to get rid of that root or that square, and the opposite of square is a square root. So this lesson will focus on how to use roots to solve equations. Now, it doesn't have to just be a square root. It could be a cubed root or a fifth root or a fourth root, depending on the highest degree that you're trying to solve for. Okay, so let's kind of jump in. Remember that if we had x squared equals 9 and we were trying to solve for x, that we need to clear the square, and we said that we can do that by finding the square root, because taking the square root cancels the square. So the square root of x squared is just x. The square root of 9, we recall, the principal root would be 3, but for what we're doing today, in this section, we're going to need to acknowledge both roots. Okay, that could be positive 3 or negative 3. Recall that you could take 3 times 3 equals 9, or negative 3 times negative 3 would also equal 9. So we're going to include both of these and write it as plus or minus 3. Okay, so our basic process, and I'll give us the steps here. In order for us to be able to cancel out the square, we want to isolate it on one side first, okay? Or get it by itself. So we're gonna isolate, in this case they're calling it the squared quantity. My spelling, sorry guys. The squared quantity, meaning whatever that value is that's being squared, get it by itself. If there's a plus or a minus around it, go ahead and move those things over by doing the opposite on both sides. Once you have isolated it, now we can take the square root. Now this one specifically says square root because we're talking about a squared quantity. Had it been a cubed quantity, we would take the cube root, okay? And be sure to do it on both sides. All right? Then lastly, once you've taken that root on both sides to cancel out that squared quantity, now you can solve, okay? Or what they say, simplify and solve. And then of course we learned before that having more than one answer doesn't mean that both of them will work. You do need to check to make sure you don't have an extraneous root, okay? So you will then check each solution. These are our steps. Here we go. I'm gonna slide. We'll keep our steps kind of over there. So there we go. Okay. Now let's take a look at the first example. This is example 9.2a. I'm gonna need more space. Hopefully you've got it all in your notes. If not, you can always rewind it back. So we've got x squared minus 16 equals 0. Our first step says to isolate the squared term, means get rid of this 16. So we'll do that by adding 16 to both sides, so that we've got x squared equals a positive 16. Now we just need to get rid of the root. Get rid of the square by taking the square root. And of course we're going to take the square root on both sides. So now we have x equals plus or minus the square root of 16, which is 4. So we have two possible answers. You would then go back and check that both answers work. So our check would be to see, does positive 4 work? So 4 squared minus 16 equals 0. Well, 4 squared is 16, and 16 minus 16 does equal 0. So 0 equals 0 is a true statement. It does check. We would also check for the negative value. So we'll check to see if we put negative 4 squared minus 16 equals 0. Well, negative 4 times negative 4 still comes out to positive 16. And when you subtract 16 minus 16, it does equal 0. So both answers check out. So I would say our answers are both the plus and minus 4. Okay, so this is the basic process. They'll just kind of, get a little more interesting as you go along. If for some reason you ended up with a fraction that's being squared, taking the square root of a fraction, make sure that you rationalize the denominator like we did in the previous chapter. That could still happen here. But let's take a look at 9.2c. This one, a little bit larger. We've got 2x minus 1 in parentheses squared equal to 16. So in this case, our squared value is all of this, okay? I'm not going to try to do minus the 1 or plus the 1 to get rid of this. It's locked into the parentheses and is part of what's being squared. So I'm not going to be able to take this apart. The first thing I have to do is attack this square. So we'll use our new knowledge of how to cancel out a square by taking the square root of both sides. And the square root and square cancel each other out, and we're just left with 2x minus 1. I no longer need the parentheses, but I do have to acknowledge that I have two possible solutions here, right? That the square root of 16 isn't just 4, it's plus or minus 4. So now I have two different situations happening. I've got 2x minus 1 equals a positive 4, or 2x minus 1 equals negative 4. So I needed to split this up into two different possibilities so that I can solve for x. So we will solve this one first. We'll do plus 1 on both sides so that we've got 2x equals 5. We'll divide by 2 and have x equals 5 halves. On this side, we'll add 1 to both sides, but this time we'll get 2x equals negative 3. When we divide by 2, to fully isolate the x value, we're left with a negative 3 over 2. Okay? Now, we have our two solutions. Both solutions would need to be checked to make sure that they work. So we'll be taking our 5 over 2 and plugging it in for x here, as well as our negative 3 over 2 and plugging it in for x here to make sure that they work. All right. I may have to leave that for in-class practice because my video is getting a little long. I gotta shorten it today. But you would plug it back in. Like you're gonna take this value. Oops, move the whole board. You're gonna take this value and put it in for x to see if it equals 16, and you're going to put this value in for x and see if it equals 16. All right, see you in class.